Good people of the channel, I have bought this, and I have a very important question that I need your help with so that I can answer a crucial question. Also, it's quite useful in that it helps me do medial deltoid raises, like this.
This series is the story of the new amphibious Arctic vehicle project named Bernard. Building on ideas, skills and questions raised during the Allen lifeboat conversion, as a team we will share all those moments needed to get Bernard up north, onto the ice and making himself useful.
The lift as well.
What a titanically inappropriate use of AI image generation. Still, does the job. Yes, I know, this is getting rather silly now. We are going to be talking about suspension and drivetrain in this episode, and there is a very key decision that I need to make, and I am going to be outsourcing wisdom to you lot for that. First though, I'll just give you a very quick update of what's going on in the cutting room. Much of my week has been spent making sense of seemingly endless quantities of fibre and moving my two collections of rolls together into my temporary cutting room near the yard. These rolls were gifted and I checked the lengths. Weighing them would have helped if I had known the weight of the heavy cardboard cores to subtract, and yes, I carefully cleaned the floor first. Anyhow, about 20 hours later, we have labelled piles. This is the heavyweight unidirectional carbon, and this super heavyweight triaxial glass for a few solid sections of laminate we need. I did find a few time-saving tricks, especially with the heavy ones where folding a consistent seam is straightforward, and this warehouse is not a patch on Vanguard, hot and stuffy, hence my limited clothing. We should be done and out soon enough though. I also found metal framing or set squares can accidentally damage woven cloth, so decided to make a more sympathetic one from graph paper. It's important to get the cuts square, or else the laying up on lamination day will be chaos, and not the fun sort. It's especially the case with fragile weaves like 200 GSM 22 twill weave here. Paper has its uses, still. Pinging back to much thicker ones, yet another new gadget. This saves both time and the survival of my hand, but I do find they create a little cloud of miniature cut fibres which causes a lot more skin itching than simple scissor cuts. This is more unidirectional carbon, but 200 GSM instead of the bulking out 600 GSM stuff. This will form the 0 and 90 degree stiffness across the bulk of the monocoque, and will be easier to handle than huge sheets. It was also exceptional value for money and sourced from East Coast fiberglass supplies. Over 100 kilos nearly ready, and now back to my medial deltoids. Right, now for the main course. Now, we all know that we're going to be fixing 6 wheels onto the Bernard Arctic vehicle. They're going to be tweels of some sort, which means they're going to be airless. And that means that I'm hoping to be able to take a lot of shock and undulation through the wheel before it even gets to the main structure of the vehicle itself. But that doesn't mean that we're going to completely write off the idea of having suspension altogether, because suspension, well, there's a reason why most vehicles have some. And I've been looking at obviously some of the other vehicles on the market. So there are the Sherp vehicles, which are the Ukrainian sort of hyper ATVs. They're very popular. They're used all over the world in swamps and also in the Arctic. I found one up on the Alaskan North Slope, and they work. They're kind of cool. They handle pretty well. Obviously, they're designed for robustness rather than ride quality, but they don't seem to fall to pieces. So I'm definitely not going to discard the decisions that the Sherp manufacturers have used. But also there are the Burlak vehicles, which are Russian built, I think. There's the Yemelaya special Arctic vehicle, or special mobile unit they call it, which has crossed the Arctic Ocean. They work too. They're built more on an aluminium. I don't know whether their chassis is steel or aluminium, but most of the shell of the vehicle is aluminium. But they have from what I can see online, and there aren't that many images, I think it is a standard sprung wishbone suspension. There are lots and lots of ways that we can look at doing this, and I need to make decisions at the shell lamination point to decide how I'm going to be thinking ahead to putting in the drivetrain and the suspension, because I need to have reinforced solid bits of laminate in certain areas, and if I don't do that now, I may have to try and retrofit, and that's just never going to work for a monocoque chassis. Monocoque chassis? Just a monocoque. Right, so we need to decide whether I'm going to separate the bits, let's not give them a name at the moment, the bits that I'm going to be fixing the wheel on, which then attaches to the shell, whether I'm going to be separating that from the drivetrain, because of course the wheel needs to be able to take the weight of the vehicle, or a portion of the weight of the vehicle, although of course with some wheels sometimes being up in the air, you'll need to have each wheel being able to take more than 1/6 of the weight of the vehicle. And then it needs to be able to transfer power from the motors to the wheel. Now, there are a number of ways of doing that. You could go down the Sherp method, and I was quite surprised when I saw this. Sherp have decided to basically have no suspension on the vehicle itself. There are no springs, there are no dampers, and there's no leaf spring suspension either. It is simply wheels bolted onto the steel chassis, and they've relied on the enormous squishiness of their big balloon inflated tyres, which are low pressure, but they're still inflated, to take all of the ups and downs, the impacts, I assume also axial forces and bashes from all different planes. Basically, the wheels take the brunt of everything, and that's a ballsy move, because you just know that if any shock transmits up into the hub, which is attached to the vehicle itself, that impact could then transmit energy to places that you don't want it to be, and in particular into the transmission and back to the engine. It worries me a bit, but it seems to work. It seems to work for them. But it relies on the fact that their wheels are a very special design, and we're not copying their wheel design. Bernard is looking to have airless tyres, which again, the same principle remains. We want to be able to have low pressure at the point where the surface of the polyurethane wheels meets the surface. That needs to be a large surface area to spread the weight out, stop us digging down into the snow. And also, if it is going to be the non-inflated equivalent of low pressure, that makes sense, squidgy, let's call it, then that should be able to take a lot of impacts, ups and downs, undulations on the terrain. But also, I'm thinking about knocks from the side, twisting forces, all sorts of other things. I wonder whether it is wise to follow the 99% of all automobile manufacturers throughout history, and to have a suspension system whereby the weight and the impact and the vibrations and so on of the motion of the vehicle over ice, ground, whatever it is taken by one thing, that is suspension, and then we isolate the drivetrain itself, the spinny bit, which transfers power to the wheel through another system. Of course, they're bolted together, but you're not asking the axle, and in our case, it's going to be an independent axle for each wheel. You're not asking that to take both the weight of the vehicle through the wheel and also the rotational forces of actually sending power to the wheel. It's a hell of a job. And what I decided to do was, jokes aside, buying one of these. This is an all-in-one drivetrain axle with constant velocity joints, designed actually for a Mercedes van. And you may think, well, that's slightly strange. I was trying to find a short one, because the motors for the vehicle are going to be so close to the inside of the shell of Bernard. There's not going to be a huge long axle running all the way through the 2 meter wide vehicle. I want the motors to be as close to the sides as possible, so these need to be as short as possible. This was basically the narrowest that I could find, and it's so hard to buy car components online. I've never really had to do it before, but the way that these search engines work on the websites, and they're all exactly the same, they probably use the same directory of vehicles. It's absolutely maddening, because what you can't do is type in length, type of spindle, number of teeth on spindle, whether you want a flange, whether you want an ABS connecting bit or not, how long you want the shaft to be in the middle, what material you want the boot to be. You can't select any of that. All you're allowed to type in is your model of your vehicle, and it just gives you a list. And it's ridiculous, because then I don't know whether a Mercedes van has a short one or not. I just came across this by accident. And as it turns out, I don't think you can get any setups. This is just over 50 centimeters. I don't think you can get any shorter than this. This is about as short as they get. For a fully articulated, there's the bendy bit, and plunging, this is much harder to do. You have to normally get your foot behind this. There we are, it does move in and out. Obviously, the forces involved are much larger, so there's a plunge at this end, because if you don't have a plunging end, then as the wheel moves, it won't just move like this, it will also move up and down. You'll end up putting massive forces through your drivetrain, and you'll probably break it. So you've got to have a plunge somewhere in the system. So you have not just that movement, but also a linear motion as well. But yeah, it was kind of like just blind luck trying to find one of these. And also some of them have spindles both ends. This one does actually have a spindle on one end. I've put the hub on. Let me just take the hub off quickly. This, again, you type in the vehicle number and then you get all the different, the vehicle make and model, and then you get all the relevant supposedly compatible parts for it. So there's a spindle obviously with the hub thread on that end. This end is a solid flange, which I'm anticipating would be a candidate for attaching to a custom coupling. Again, you can't just type in, oh, I want a conversion from a flange of this diameter with this number of bolt holes connecting to a IEC standard keyway solid shaft, which is what's coming out of our motor. You can't just type that into a catalog online and it finds one for you. It's absolutely mad. I don't understand why they can't run their search engines, both for vehicle make and model number and also just for the actual numerical dimensions and design decisions, like whether this is a flange or a spindle. Anyway, life goes on. I'm probably going to have to get those couplings custom made, so we'll probably get an exciting inside of a factory episode at some point having those made. It's certainly beyond my ability. I don't really know how to use a metal lathe. Anywho, this is for the Mercedes Vito, and it's not stainless steel. I've long since run out of optimism for trying to get my drivetrain made out of stainless. I know that stainless steel, there's a reason why a lot of things are not made out of stainless steel. It's not just cost. Most engineering steels which are not stainless perform better. They are tougher, they can deal with better torsional forces and so on. So it's not just people being cheapskates, it is often better to do it that way. So the chance of having a completely corrosion resistant drivetrain, it's for the birds, and so we're going to have to come up with some probably marine grade greases to try and keep everything safe, and perhaps I can epoxy coat some parts which won't be dealing with wear. So also on buying these sorts of things, there's not just one manufacturer that makes them. You don't buy them from Mercedes, there's a million of them. So it comes up with a list of about 20 of them, all of which look exactly the same as this, of course, because it's all for the same vehicle, from lots and lots of different manufacturers. And so I had to do a deep dive into what manufacturers are which. The price range is massive. Like this was about 60 quid. You can get some down below 50 quid, but then I did a very quick search and it turns out that those companies you don't touch with a barge pole. They've got a terrible reputation. I won't name and shame them, otherwise I'll get sued. And then up at the upper end, you get ones which are £200 or £300 from companies like Timken, SKF, FAG. They're apparently, when I actually get into proper manufacturing, when I go into real purchasing mode for getting 6 of these for a vehicle, I will obviously go for the best manufacturer. I decided, because this is just like a test, and because I've never held one of these in my hand before, which is why I'm using it as weights and generally just spending all my time with it. It's something I'm just so not familiar with. I want to get a sense of how it all fits together, just become a little bit more educated. And so I thought I won't go for the proper cheapie. I'll go for one which is a little bit above the standard. And it was from a company which I gather is sort of mid-market called Febi Bilstein, which apparently they're not the cheap and cheerful ones, but it is worth going for top of the range when we actually come around to getting them for real, if we get one. So those of you who are into large vehicles, particularly extended suspension travel vehicles, there are lots of people who modify their 4x4s and their trucks, over in the US and all over the place. Anyone who actually has some genuine experience with these sorts of things, what are your thoughts? Just, use the comment section and have fun with it, because this is something which I'm just not familiar with at all. And this is my quandary. The simplest solution would be to almost kick the can down the road in terms of taking impact and stresses and basically saying, oh, no, it'll be fine. The wheel will take all that. We'll design the wheel so well that it will just take care of all of that stress, pressure and attack from the outside world in the way that the Sherp manufacturers have. But their wheels are clearly phenomenal. That makes me a little bit nervous, because what they're doing is simply having the hub bolted onto the outside of their chassis, and they just bolt the wheel onto that. Super simple, easy to maintain, and so on. But I worry about the fact that you're asking one thing which is transmitting power, but it's also taking the load of the vehicle all on one item. Now, the other solution which I was more or less settled on, and I'm now unsure about because it is more complex, is separating the two out. Hopefully this makes sense. I wanted to mount each wheel on a suspension unit, not a sprung unit, not a leaf spring, not a spring, but instead on a torsional axle suspension, which is basically where you have, it's normally box section within a larger bit of box section with very special, really hard to nail down what rubber this is, but very special rubber which uses torsional resistance as it starts to rotate, as the wheel moves up and down on an arm, comme ça. That rubber resists and basically takes away a lot of shock and impact and so on, and just give that wheel a little bit of movement up and down. It's really clever. Trucks use them. I've put a couple of diagrams of them in previous videos, but I'll stick one in the overlay here so you can see what I'm talking about. And then coming out of the vehicle without the need to take the load of the vehicle, the actual weight of the vehicle on it, you simply have the drivetrain, which runs through a spindle on the edge of that arm on the suspension unit, and you simply plug the spindle through the end of that arm. Hub goes on, locking nut goes on. By the way, this bolt here, I was really confused about whether it was supposed to be designed by this, but I'll just do a little addendum onto that in a second. And then obviously at some point, this will pass through the shell of the vehicle. You've got to then work out what sort of glands you're going to have to try and weather seal it. Whether you have it come through the vehicle shell here, around the shaft, or whether it won't be as far back as here, but maybe around there. There are all sorts of ways of doing it. But that would then simply mean that the only forces going through these are rotational, because the articulation and the plunge is taking care of any movement of the wheel. It's much more complex. It is more elegant, and I think it might still be the cleverest way to go, but I need to make a big decision about this. I worry about doing away with these altogether and simply putting a super robust, solid laminate mount on the shell of the vehicle, which then has an axle coming directly from the motor out of the vehicle through a high quality mounted bearing like this. This is very much bigger and heavier and stronger than the bearings that I was showing you in a previous episode, which is going to be for my snow sledge. This one has got a big 40 millimeter internal diameter, whatever you want to call it. Anyway, this is a quality, this is steel as opposed to thermoplastic, and so this will be mounted into the shell of the vehicle. Axle will pass through the drive shaft, and then the wheel would simply mount on the outside. But then, what are you actually supporting the weight of the vehicle on? The shaft is passing through here. This is the shell of the vehicle, and then the solid shaft, the solid keyway shaft of your motor output is here, and you've simply got your shaft passing all the way through. You've only got two things supporting it. That is going to be potentially hundreds or even over 1,000 kilograms of lateral force as the wheel is moved up and down and impacted by the environment outside through those two structures. I'm not sure if I like that. I would at least want it to be passing through two of these. But where would they then be? You would then need to build a structure with at least a bit of a distance inside the vehicle to support that and keep the shaft straight, and to stop it applying stresses to my motor output, which I don't want to be stressed. Which makes me think whether it's a better idea to go the long circuitous route, put the work in to get these torsion axle suspension units designed and made, so that you have one of these simply passing through the shell of the vehicle to transmit the turning force. Right. Those of you who do trucks, vehicles, or are mechanics of any sort, let me know. I've had input from people who are in that world, both friends, professional friends, and family. And so I won't give you a lead on what they've said so far, because I don't want the purity of your input to be compromised by other ideas. Let me know what you think. And also what I was just mentioning to you a second ago, before I forget, one good thing is that this fitted first time and I was very happy with it. So basically inside the hub, which is very heavy and really rather beautifully engineered actually. I like stuff like this, which is why I'm quite happy that some of the Bernard vehicles going to have, you know, steel fixings and not everything's going to be carbon fibre. So that slots onto the spindles rather nicely, slots all the way to the bottom. And then this, it turns out, is a one-use hub nut. You don't take this on and off, because I was spinning it on, just, you know, having a play just to see how everything works and make sure that all the threads mesh together nicely. And then it sort of, bear with me, right, it went on, but then it's not fully on. There's still movement there, and I thought, that's strange. Then I noticed there are 2 indents in the top of the thread, and it turns out that when you torque this up with a torque wrench to 1,000,000 Newton meters, like I suspect is required, it obviously then deforms those, it reforms those deformed threads, there we go, and basically acts as a lock. So you'd have to use Loctite or something like that. But of course, then you have permanently changed the thread, and that will be a single-use thing. So obviously, I won't do that now. I was just, yeah, it's just intriguing. I guess that makes a huge amount of sense, because you're not going to want to take these off and on without replacing the entire unit, or at least having a new nut. So having them as a single use where you deform the thread using huge amounts of torque is rather clever. I like that. That said, I'll have to keep that in mind for field repairs if we did need to take them off from hypothetically something similar to this in the future. We need to have some spares. Good to know. Rather like this. Oh, and the other final thing is these boots are polyurethane, and they're rated to -20. That won't be quite enough. Apparently, it's quite simple to have these off. I might need to change over the grease inside this anyway, so we'll probably have to take them off and do a little bit of maintenance. But you can get these replaced with silicone boots. It's just to keep all the grease in there and stop contamination from the outside world getting in. And so we're going to have to open that up at some point. I think that's probably everything. I think I'll leave this episode there. This week has been a lot of work in the cutting room, getting all that fabric ready. And I've got to get ready the bonus episode for channel members, which I'll get done in the next few minutes. That'll be exciting. That'll be on a sort of a slightly adjacent expedition topic and manufacturing something which I've been looking to do for quite a while. That will hopefully be interesting for people. And I'll also get the personal little video clips done for those of you who are top level, top tier Wonderment members. And those people get a special extra video addressed specifically to them every month. We'll get those done as well. Until then, I will continue using my components of my Arctic vehicle as gym weights. And I hope you have a good weekend. Bye.